Okay, today's lesson is lesson number 58. This is domain, range, intervals, and trends of graphs. So we're going to look at some properties and key characteristics of different graphs. Okay, here's our first set of definitions. So domain is the set of all possible x values that can be used as inputs for a function. Range is the set of output values, so the y values. Then the max is going to be the highest output value or the largest y value, and the minimum is the smallest y value. Okay, the next two definitions are increasing and decreasing. So I have an increasing interval. Okay, it's part of the domain, so we're concerned with the x's, the x values. And I'm increasing when I am increasing in my y value as I move to the right on the x. So I think if I'm standing on my function and I'm trying to walk to the right, I look at what happens. So as I try to walk to the right, on this first image, I'm forced to walk uphill. So I say that my function is increasing for those x values. Okay, so on that interval, I would be increasing. Okay, then for decreasing, if I'm standing on my graph and I try to walk to the right, I'm forced to go downhill. Okay, so the y values decrease as I walk to the right. Okay, and I would say that I'm decreasing on this interval. Okay, and the last concept for today we're going to talk about is what's happening as x goes to infinity. So as x is getting really big, what's happening with my y values? And as you can see, this is going up as we go bigger in x. Y is just going up forever. So I say that y goes to infinity. And I can write it just with an arrow like that as well. Alright, so for this first graph, we're going to look at all of these characteristics. Now this is just a line, so it's not too exciting, but for the domain I'm going to look at my x values. So I'm going to see where this function exists, right? So for the x values I don't have any problems, so I would just say the domain is all real x. Or I could write that as the interval from negative infinity to infinity. Okay, and again, domain is just asking you which x values you could plug in and get something out, and as we see, this is a line, so it just continues on and on, so I can plug in any x value. Range now is talking about the y values, so I'm looking here, and again, the arrows indicate that I go up forever and down forever. So I will get all possible output values, so I could say that my range is also from negative infinity to infinity. Since I go up forever, I don't have a highest point, right? I could always go bigger, so I don't have a max, and then similarly for the minimum, I go down forever, so I don't have a minimum. And if I stand on this graph and try to walk to the right, I'm forced to go uphill. So I'm increasing this whole time. So I'm increasing from negative infinity to infinity because this line is always constant, right? It's a constant slope. So I'm always going uphill, which means I'm never going downhill, so I'm not decreasing. And as x gets really big, as I go off to infinity, I see that y is getting really big as well. So I say y goes to infinity. And I can write these intervals as inequalities like this. So for the domain, I could also write that as negative infinity is less than x is less than infinity. And same thing for the range, but with y. Okay, for the next example, this is a piecewise function. So it's two different pieces put together. And I see this closed circle and open circle. So those are going to be important for me to consider. Okay, so we'll start by looking at the domain. I see my function starts here, right? There's nothing else to the left of that. And it's a closed circle at -5, which means that I include that point, just like when we were shading the absolute value inequalities. So I'm including -5, so I write it like this. I use a closed bracket to go along with that closed circle. Okay, now I'm looking, where else does my function exist? Where are there possible x values? See, all of these are good up until I reach 5, and then I hit that open circle. So my domain goes from -5 to 5, and the open circle means that I don't include it, so just like with infinity, which we can never touch, here on this graph we can never touch the 5, so we use an open parenthesis there. Okay, now for the range, I'm looking at my y value. So what happens as I go up? Oh, and this can also be written in the inequality form. Okay, so now looking at y values as I go up on my graph, I first hit a y value here at -2 at that open circle. So I'm going to use an open parenthesis, then -2, and it goes all the way up until I hit this point, which happens at 5. Again, that point is included, so I use a closed bracket there. And I can write it like this. Okay, so the highest point of my function happens right here, which has a y value of 5, so my max is y equals 5. The lowest point happens at that open circle, so y equals -2 is the lowest point, or my minimum. Now I'm looking, okay, what if I'm standing on this graph and I want to go to the right? What happens? So first I go uphill, this curvy path. Even though it looks kind of funny, it's still uphill the whole way. So I'm going uphill or increasing up until this point. So from -5 all the way until 2. Remember, we're looking at the x values here. So from -5 until 2, I'm increasing. Okay, then after that, if I stand on the other side of that point and I try to walk to the right, I'm forced downhill. So I go downhill for these numbers in red, those x values, so I say I'm decreasing from 2 to +5. Okay, now as x goes to infinity, well, on this graph, my x is limited, right? My domain isn't infinite, so it doesn't go to infinity, so I can't really consider that. Okay, for this next example, I have arrows again. This is a quadratic function, so my domain is going to be -infinity to infinity. Again, it's going off. These arrows tell me that it's going off forever in both directions, so I'm not going to have any problems with my x values. Okay, then looking at the range, it goes all the way up and then it stops here. So my range is going to be -infinity to 4. And I include 4 because this point is included. Okay, my max is then y equals 4, and since it goes down forever, I don't have a minimum. If I'm standing on the far left side of this graph and try to go right, I'm forced uphill. So my first interval is increasing. I'm increasing for all these values until I hit the top of the hill when x equals 0. So for my interval, and then after that I would be going downhill, right? So my increasing interval is -infinity to 0. And then I'm decreasing after that from 0 to infinity. Okay, again, these are x values. So you're talking about for which x values are you going uphill or downhill. Okay, then as x goes to infinity, y is going down here. So we say y goes to -infinity. Alright, and last example, this is an absolute value function. And the domain, we can see for the x values, I don't have a problem. So I say that my domain, again, is all real x, or -infinity to infinity. Okay, and then for my range, I see that my graph doesn't start until right here, right? Nothing's going on here. So my range is from 1 to infinity. And again, I bracket that 1 because it's included, right? That point exists. And it goes up to infinity, so that's the upper end of my range. Since it goes up forever, I don't have a maximum. And the minimum happens at the very low end of the range, which would be y equals 1. If I'm standing on my graph as far left as I can go and I try to walk to the right, I I'm forced downhill first. So first I'm decreasing, right? So that's from negative infinity until I hit this point. So -2, right? For all of those x values, I'm walking downhill. Then in red, I'm walking uphill once I get to the second half of that graph, right? So my increasing interval would be from -2 to positive infinity. And then looking at the trend of the graph as x is going to infinity, this arrow is going up forever, so it looks like y is also going to infinity. All right, and that is it for today's lesson. Thank you.